This part is called more special products, but in fact there's really only one type. Remember that when we're multiplying binomials, we're going to take the first term in the first group and multiply it by all of the terms in the second group. Then we're going to take the second term in the first group and multiply it by all of the terms in the second group. This gives me x times x, which is x squared. Then x times negative 2, which is minus 2x. That's the x taken care of. Let's move on to the 3. 3 times x is 3x. And 3 times negative 2 is negative 6. Combining like terms, I get x squared plus 1x minus 6, or if you'd rather, just x squared plus x minus 6. At this point, I'll still take either of those. Instead of x plus 3 times x minus 2, what if I had x plus 3 times x minus 3? In other words, what if both the letters and the numbers in my two binomials were the same, but the signs were different? In the last part, I did a problem like this. I ended up rewriting it as x plus 3 times itself. The x's are the same, the letter, the variable. The number is the same. And the signs are the same. The difference between this problem and this one is that the signs are different. That's the only difference at this stage. But watch what happens when we work this one out. X times x is x squared. X times negative 3 is negative 3x. Moving on to the 3, 3 times x is 3x. 3 times negative 3 is negative 9. Combining like terms, I get x squared plus 0x minus 9. The negative 3x's and the positive 3x's, when you add them together, that's what combining like terms is, add up to 0. I have no x's. So actually I can rewrite this one more time as x squared minus 9. Here's a similar problem. The sum of two terms times the difference of the same two terms. In other words, the first thing in each set of parentheses is the same. And the last thing in each set of parentheses is the same. The signs are different. Distribution gives me x squared minus 5x plus 5x minus 25. These two terms add up to 0. So I can rewrite this as x squared minus 25. See the pattern? A plus b times a minus b is a squared minus b squared. My a here is x, so my a squared is x squared. My b in this case is 5, so my b squared is 5 squared, or 25. Does the binomial with the plus in it have to come first? No. Watch. X minus 7 times x plus 7. The pattern is the same. The sum of two terms times the difference of the same two terms. Using the shortcut, a is x, so I should get x squared. B is 7, so I should get 7 squared. And I should get a minus between them. But let's double check. X times x is x squared, and x times 7 is 7x. Negative 7 times x is negative 7x. And negative 7 times positive 7 is negative 49. Combining like terms, I get 0x for my middle term. I never finished this one out, but notice that either rewriting this or rewriting this without the middle term, I get x squared minus 49. Let's do one that's just a bit more challenging. 5p plus 8q times 5p minus 8q. Now, you can use the shortcut on this one as well, but you have to be careful. Let's do it the long way first. 5p times 5p. In the next step, this is going to give me 25p squared. 5p times negative 8q. In the next step, this is going to give me minus 40 times p times q. Now for the other term, positive 8q times 5p in the next step will give me plus 40 times p times q. And lastly, 8q times negative 8q will give me negative 64 q times itself, or q squared. This becomes 25p squared, and notice that once again the middle two terms add up to 0. This time what I have none of is pq's, minus 64q squared. Since I don't have any of these, I don't need to write it. And my final answer looks like this. That's the long way. I'd like to do this one using the shortcut too, because I want to point out a very important thing to be aware of. We need to be careful about identifying what our a's and our b's are. A is the first thing in the parentheses, the first term. A squared, therefore, at least in this case, is going to be 5p squared. Not just 5 squared, and not just p squared. What's my b? Well, in this case, it's 8q. So, if I'm going to subtract b squared from a squared, I need to make sure that I get the right thing for b. Now, remember that product rule for exponents? A product raised to a power is equal to the product of each of the factors raised to that power. That's what's happening here. If ab to the r is a to the r times b to the r, then 5p to the 2 is 5 to the 2 p to the 2. And this is times, and this is times. I have the same thing here, and I'm going to subtract it from the first part. 8q squared is 8 squared q squared. Now I can simplify. 5 squared is 25, and 8 squared is 64. My answers match. No surprise, because this shortcut that I took is based on the fact that this happens every single time. When you have a product of two binomials that takes this form, the answer will always take this form. Okay, one last thing in this part, and that is to compare the shortcut learned in this part to the shortcut learned in the previous part. Let's go back to a simpler problem. We learned here that x plus 6 times x minus 6 can be shortcutted, if you will. This is a plus b times a minus b. Then my result will be a squared minus b squared. But that only works if one of the signs is positive and one is negative. If they're both positive, I can use a shortcut, but I have to recognize which shortcut to use. This comes from x plus 6 times itself, or x plus 6 squared. So I need to use the shortcut a squared plus 2 times a times b plus b squared. And that gives me x squared plus 12x plus 36. This is because x times x is x squared, x times 6 is 6x, 6 times x is 6x, and 6 times 6 is 36. And combining like terms, can you see the difference here? It's tempting to say these two are the same and these two are the same, so you just square them both. And whatever sign you've got, well, it doesn't work that way. To get rid of the middle term, you have to have one of each. If you have two the same, you will have a middle term. It might be positive or it might be negative, but it'll be there. Let's do the example where the binomials are the same, like this one, but the sign's minus instead of plus. Using the shortcut, I'll get a squared, because my a in this case is x, plus 2 times a times b. The thing in the position of b is negative 6, plus b squared. And that's x squared minus 12x plus 36. Using distribution, I would get x squared minus 6x minus 6x plus 36. Combining like terms, I'll get minus 12x. So whether I use distribution or my shortcut or formula, I get the same answer, but only if I'm careful to use the right shortcut for the right type of problem. Shortcuts are fine. They can save you a lot of time, but saving time at the expense of the right answer really isn't worth it.